Welcome to our chemistry tutorial. You're either here to cram for a test that you have soon, or Miss Houchin is being very nice and allowing you to watch a video before you actually end up learning, which you should not take for granted because we rarely watch videos and we love them. So ask her about Hank. So today, me and my friend, or colleague, Victoria, will be showing you a video about redox reactions in chapter 20. But as you can see, we are soon to be graduates, but not yet, because Miss Houchin is making us shoot a video, and so we're here to teach. So Victoria, if you would please welcome my colleague Victoria Preston, who's going to help us today learn about reduction reactions. And this is the first part of our notes. We're going to do a couple sections, and I just went ahead and wrote it shorthand for you in case you're taking notes, so Victoria is going to explain a little more.
Okay, so redox reactions are an abbreviation for oxidation reduction reactions, and they are chemical reactions in which the oxidation state of one or more substance changes. So during this reaction, electrons are exchanged by reactants and products, resulting in changes in oxidation states. And oxidation states indicate the number of electrons that substance gain or lose when it forms a bond. Okay, so next we're going to be covering oxidation rules. So basically the first rule is that the oxidation state of an atom that is not bonded is equal to 0. The second rule is that the oxidation state of all atoms and molecules is equal to 0. And the third rule is that the oxidation state for all atoms and polyatomic ions add up to the charge of the anion. An example is hydroxide. So the fourth rule is basically, it's not really a rule, but it's just that you know the charges for the groups on the periodic table and also on the polyatomic ion.
Okay, so the next thing that we're going to talk about is how in redox reactions you actually split the one reaction into two half reactions, one for oxidation and one for reduction. So let's start with oxidation. Oxidation is where the atom loses electrons, and a memory trick for this is Leo, the lion says grr, and oxidation is the Leo part, so loses electrons, oxidation. And something that can be a little confusing is that the reaction is oxidation, but the thing that's actually losing electrons can be called the reducing agent, but it's not the oxidizing agent. It is the reducing agent because though it is being oxidized, it is causing another thing to be reduced. So it can also be called the reductant. So on the reduction side, it's where it gains electrons. So Leo, the lion says grr, so gains electrons, reduction. And like oxidation, it's the opposite, so it's the oxidizing agent, because though it is being reduced, it is because it is causing another to be oxidized. And it can also be called the oxidant. Oh yes, so my camerawoman just gave me a note to remember. So from now on, as you can see, we color coded this, and from now on we are going to do two examples for you, one in basic solution and one in acidic solution. And the things that represent the oxidation half reaction are going to be in blue, and the reduction half reaction will be in red. Okay, so our first example is going to be a basic solution example, and you know this is a basic solution example, one, because it'll have to tell you, and two, there is a hydroxide group right there. So the first thing you have to do when balancing a redox reaction is split the reactions into two half reactions, an oxidation reaction and a reduction reaction. So you take like things and split them up. So I'm going to move this NO2 down to another reaction. And the NH3. So now we have two half reactions, one with aluminum and one with NO2 minus. This one is going to be our oxidation one because aluminum is losing electrons, which will make more sense later. And NO2 minus is gaining electrons, so this is our reduction half reaction. So now I'm going to start off by balancing the top reaction first. And the first thing you need to do is make sure that all elements besides hydrogen and oxygen are balanced. And the only other element is aluminum here, and there's one on each side, so we're good. Then you want to balance oxygen by adding H2O. And here there are 4 oxygen, so we're going to add 4 waters to this side, like so. The next thing you want to do is add hydrogen, so there's 4 on this side and 8 on this side, so we need to add 4 more hydrogen to that side. We're going to walk it this way and add 4 right here. And then for a basic solution, something a little bit different than acidic is the amount of hydrogens that you add. You have to add the same amount to both sides with hydroxides. So you have to have 4 hydroxides on this side and 4 on that side. So let me do that real quick. So we have 4 right there, and then another 4 has to go on this side. Now everything is balanced with element wise, but now we have to check on charge. So on this side, these 2 are neutral, they don't have a charge. This has a 4 minus charge, so this entire side, or reactant side, has a 4 minus charge. On this side, we have 1 minus with aluminum hydroxide. But these 2, a 4 minus and a 4 plus, cancel each other out. So we have a 1 minus and a 4 minus. So since it's also oxidation and aluminum is losing electrons, we need to add 3 electrons to the product side. Okay, that's gonna work for now. It's fine. And, so now our charge is balanced on both sides. We have a 4 minus total for reactants and a 4 minus total for products, and you're done with the first one, reaction. And again, we look at all the elements that are not oxygen and hydrogen and see if they're balanced. We have 1 nitrogen on each side, so we're good there. Then we want to balance our oxygens with adding water. So there's 2 oxygens here, so we're going to add 2 waters to the other side, like so. Now we want to look at our hydrogen. From NH3 we have 3 hydrogen, and from 2H2O we have 4 more. So we need to add 7 hydrogen to the reactant side. 7H plus. Now again with the basic solution, special thing, we need to add 7 OH minus to both sides because it's in basic solution. So I'm going to do that. Here's 1. And the other. Now to simplify things, right here we have 7H plus and 7OH minus, which together makes 7H2O. So I'm just going to go ahead and simplify that right now, make things a little simpler for us. You could have also done that up here. I just didn't feel like it at the moment. And the last thing we need to do is balance charge. So here we have a neutral and then 1 minus on reactant side. Here it's neutral, neutral, and 7 minus. So we need to add 6 electrons to this side. So we'll have a total of 7 minus and 7 minus on both sides. Okay, now everything is balanced, and then you have to add, no, everything is balanced in each reaction, but we need the amount of electrons in both half reactions to be equal. So we need to multiply this above oxidation half reaction by 2, because we have 6 electrons here and only 3 here. So we're going to do that real quick. Okay, so now I have multiplied the entire oxidation half reaction by 2, so we have 8 and 2, 2, 2, 8, 6. So now our electrons will be equal, which means they can cross out in the end. Now here, as we did below here, we can add the 8H plus and 8HO minus. O minus. OH minus. You know what I mean. To combine 8H2O. Like this. Shift everything over. So, everything is simplified. So now we need to add the two half reactions together. And all I'm going to do for that, because there's a lot of things going on here, so I'm just going to put this right in the middle here. So all of these, blue and red and black, are reactants. And all of these are products. Now from here we can start eliminating things that are the same on both sides. So like these 6 electrons, I feel like Vanna White. If you don't know what that is, you should learn. It's a great show. Okay. And then we have, yes. So 8 H2O, both sides. Now here we have 2 H2O and 7. So they don't go out completely. So I'm going to simply simplify. Now, I'll take the 2 away, which means I will subtract 2 from the 7, so the remaining 5 will still be on the reactant side compared to the product side. And there are 8 hydroxides on this side and 7 on this side. So again, they don't completely cross out, but you can subtract the 7 from the 8 on this side, leaving 1 hydroxide left, again on the reactant side because there was the larger number on the reactant side. And so we can move this all around and get our final reaction. And we have 1 hydroxide plus 5 waters plus 2 aluminums and 1 NO2 minus creates or reacts together to make 2 aluminum hydroxides and 1 NH3. The end.
And we're going to do a redox reaction in an acidic solution. So the first thing you want to do is you want to separate the reaction into 2 half reactions. So to do this, we're going to separate it into the 2 with like terms. So the first one is copper solid to copper 2 plus, and then the second one is NO3 minus to NO2 gas. Okay, so the second step is to balance the half reactions. The first one we're going to do is the oxidation reaction. So first you want to balance anything other than O and H, and since copper is already balanced and we don't have O or H, then all we have to worry about is the charges. So on copper, there's no charge on solid copper, and there's a 2 plus charge over here. So we're going to add 2 electrons to this side to balance. Okay, so the next step is to balance the reduction reaction. So the first thing we're going to do on that is balance anything other than O or H, but nitrogen is balanced on this, so we're good there. Then we're going to balance out the oxygens. So to do that, we're going to add H2O to this side, because there's 3 oxygens on this side and only 2 on this side, so we add H2O to make it 3 oxygens on that side. Then we balance out the hydrogen ion, and to do that we want to add 2H plus the left side, because we just added 2 H's on the product side with H2O, to balance it out with 2H plus on the reactant side. The final step is to balance the charges. This side is neutral, and then this side has a +1 charge because there's 2 H pluses and just one NO3 minus. And so to balance that out, we add one electron. Okay, in order for us to combine these two reactions, we need to make sure that the number of electrons is the same for both. So because there's 2 electrons here and just 1 here, we're going to multiply this whole reduction reaction by 2. Okay, so for the final step, we're going to combine the reactions. And to do that, we're just going to add them together. Put that there. Okay, so while we're combining them, we can cross out anything that's the same on both sides. So we can get rid of the 2 electrons because there's 2 on this side, and there's 2 on this side. And that's all the same that's on both sides. So then the final reaction is just this. Because there's nothing else that we can cancel out on either side.
Thank you for watching our tutorial. I hope you learned a lot and had a little fun doing it. Stay tuned for bloopers. Oxygens. So we balance oxygen by adding water. So we're going to add 4 waters to this side. Like so. And now there's something special about basic. So dang it.
I'm totally recording this too.
You have NO3 minus, copper solid.
Solid copper.
Copper 2 plus, and NO2. Those think right.
How did they do that? Ma! That thing? What was the other one? I can't do it. My voice doesn't go that high. You may begin.
Oh, I already started. So. Let's run it again.
So you ready to get a 5 on your AP exam? No.